think I sound whiny today.
Okay, let's see. We'll talk about speech processor, sort of miscellaneous stuff. S meters, single sideband, operating within the band, how far you should be from each edge. So speech processors, sometimes called speech compressors, are trying to emphasize some frequencies in your voice more than others to increase the modulation and the intelligibility of your signal. Um, Unfortunately, they don't all work the same. And in some of the cheaper ones, it becomes more of a signal limiter. And at a certain power level, it just clips the signal, which is not good. What it's supposed to do is essentially increase the average power of your baseband signal, which increases the output of your single sideband signal. So one of the things that the better ones do is increase the amplitude of the soft sounds and reduce the amplitude of the louder sounds so that the average is higher. So there isn't as big a difference between the loud and the soft. Um, and that gives you more area under the curve, basically, and makes your signal more intelligible because you have more uh, modulating power. Some of the radios will also include a sound equalizer. It may be as simple as being able to adjust the low, middle, and high frequencies a little bit to kind of make the sound better, both receiving and transmitting. Some cases it may be more complex and have 11 or 15 stages where you can vary different frequencies in the audio band. Uh, if you do the adjustments incorrectly, you can actually wind up distorting the speech more than you're trying to help it. And uh, in the case of where it's starting to clip, you're going to get what they call splatter, where it's going to be generating odd harmonics. If you're increasing the soft sounds too much, you're going to pick up more of the background noise. So it's like most things, it's a trade-off to find out what the right settings are. But typically, having speech compression on helps as long as you can get it adjusted halfway decent. This is a thing I found kind of showing some speech compression. And here you see the raw speech, and you see some very high peaks down to very low. So here we've kind of reduced the overall dynamic range by reducing the peaks and increasing the soft ones. And we get this output, which is I'd say more balanced. It's probably going to be a more readable signal. I have no idea what your radio might have, whether it's got a speech compression knob or you have to go through some sort of menu system. It's a little complicated on the 7300. Next are S meters. Most radios, even handy talkies, will usually have an S meter. They may not all be calibrated. Might just be a bar graph showing you relative signal strength. What it's intended for is to display the signal strength of your received signal. It's usually marked off in what's called S units or signal units, and it's a logarithmic type scale where each S unit is a 6 dB increase, which means S2 is 4 times the signal strength of S1. S3 would be 4 times the signal strength of an S2, all the way up to S9. Now, it turns out in a calibrated S meter, S9 is usually calibrated to be equal to a minus 73 dBm signal. That means it's 73 dB below 1 milliwatt. It's a very small signal. When you get above S9, it's usually marked off in dB. Here's an example of one. So we're going S1 through S9, and then we go plus 10, 20, 30, 40. It's probably unusual to see one marked all the way up to plus 70, but it's possible. And it turns out that would be 0 dBm or 1 milliwatt, which is a strong signal. And typically they're not going to give you the dBm scale.
Can I ask you a quick question?
Sure.
You said 9 times. Sorry, four times whatever it is. So that's 9
four
times
times 9. 4 times the previous.
Okay, so if it's an S9, that's 8.
That's 4 times 4 times 4 times 4 times 4 times 4.
So it's 8 times 8 times 8 times 8. Remember, I'm not good at math, so I'm trying to figure out how did we get to 70? What was it? 72?
Minus 73.
Yeah, 70. How did we get to there? How did we go from 8? Because it's. I thought when you multiply like 4 times something, that means it's 8 4 times. 8 times 8 times 8 times 8, which does not equal 73.
No.
So I'm trying to figure out how you got 73. I'm sorry.
Oh, well, that's just the way they calibrate it. So they say S9, okay, is equal to a minus 73 dBm. That's a measurable signal level.
Okay, so I'm not going to be able to multiply that to get to.
You don't have to.
Okay, I didn't know if they were going to. They've already taken the test, so they are already familiar with it. I haven't, so I wasn't sure if they were going to give me something and I'd have to apply a formula.
No, you just have to remember that each S unit is 6 dB or 4 times the previous one.
The one underneath it, whatever it is. Okay,
right.
I understand.
They go up 4 times, 4 times, 4 times, 4 times until you get to S9.
Okay, so you're doing 4 times whatever the number is.
Right. Whatever the signal is, the next one is 4 times stronger.
Are you talking about the number to the power of 4?
No.
Because that's what I'm trying to figure out is what 4 times. How did you get to 73 with 4 times anything?
Well,
so
let's look at S9 is minus 73.
Okay, so
if I go to S8, okay, that would be equal to minus 79.
How did you get that?
Because it's 6 dB
minus
less.
76.
So 73 minus 73 plus a minus 6 is minus 79. If I go to S7, it's another 6 dB lower.
Which is adding another 6.
adding another -6.
Okay, so I
Minus
don't
6.
necessarily need to know what the times 4 is. I just need to know that S9 is -73, and then I can adjust from there.
But you do need to remember the 4 because it's a test question.
Well, see that, yeah, I'll remember that it's times 4, but I don't need
Oh,
to actually
God.
do it.
Right.
Okay, I got you.
You
I'm not a math person, so
yeah.
I was going to ask you to show me the
You
formula, but
you don't even need to remember that it's
okay,
-73.
okay, okay, I got you.
But you do need to remember that above S9, we start doing dB over. Okay. And
Isn't
that,
it all dB? It's all dB. It's just whether it's logarithmic or not.
well, dB is logarithmic.
Oh, God.
That's
dB
not
is dB is dimensionless, whereas
okay.
dBm is relative. A dBm is relative to a milliwatt. A dB is just a ratio.
Mm-hmm.
So 20 dB is 100 times. So if you have a signal that's 20 dB over S9, it means it's 100 times S9, not 4. And that one you need to remember. You don't need to remember all the others, just 4 and 20 is 100. Any other question? And there's 20 dB over.
So you said that dB is a ratio and milli
Yes.
dB is what again?
A dBm or a dBi or dBc, they're all relative to some standard.
I got you. Okay.
A,
I didn't get it written down quick enough.
a dBm is relative to a milliwatt. And that's kind of a standard measurement in radio stuff. 0 dBm is 1 milliwatt. And that's the kind of signal you may see running around inside your radio.
Got it.
Bob,
Uh-huh.
I am so lost
Okay.
But it's not just
that
me.
that I'm going to stop here. Honestly.
Okay.
No, everybody's laughing, but I'm not laughing. So I'm just going to say good day, and that's all I can do. Okay? I'll see you next week.
Well, you can listen.
All right,
Okay. That's really all you need to remember
I got you.
is the 6 dB or 4 times,
Right,
and that 20 dB is 100 times.
100 times. Got it.
Okay. When we talk about sending single sideband, whether it's upper or lower, you're normally looking at a signal. We assume it's 3 kilohertz wide. It's probably typically more like 2.8, but we'll use 3 because it's a nice round number. So if we want to operate lower sideband down at the bottom of the band, it means that we need to have our carrier frequency set at least 3 kilohertz above the bottom of the band. Likewise, if you're operating upper sideband, you need to be 3 kilohertz below the top of the band because your signal is going to be from where you are up 3 kilohertz. So you don't want to exceed the upper band limit, nor do you want to exceed the lower band limit. If you're operating somewhere in the middle of the band, that's not really an issue. And you're normally following the protocol of upper sideband above or 10 megahertz and above, and lower sideband below 10 megahertz. If we look at the 40 meter band, where you'll be able to operate as a general, it goes the voice section for single sideband for a general goes from 7.175 to 7.290. So if you're wanting to operate at the bottom of the phone part of the band, okay, and since this is below 10 megahertz, you're going to be lower sideband. You want to tune to 1.78 or above so that you're at least 3 kilohertz above the bottom. So 175 plus 3 is 178. And if you were to operate upper sideband, which isn't protocol, but you could, you'd tune to 287 so that you're 3 kilohertz below the top end of the phone band. That's just some simple math. Okay.
Here we go.
What's the purpose of a speech processor in a transceiver?
Charlie?
Yeah, Charlie or Alpha?
Yeah.
Well, you have to pick one.
Alpha.
Increase the loudness of transmitted voices. Increase the apparent loudness. No, I'm going to say Charlie.
Right, we'll see.
I don't know.
Either one, I would have
you're right.
picked.
Okay, so if you're already hearing it, this is what threw me. If you're already, it's apparent loudness, you can already hear it, then why are you increasing it?
Oh, okay. Because we're talking speech processor is on the transmitter side.
Not the receiver side.
Right.
Okay.
Now in the receiver, you could have some speech processing like equalization to make it sound better. But essentially the speech processor on the transmitter side is to increase the apparent, you want to make your signal seem as loud as possible.
Okay.
So this is in a transceiver, not a transmitter.
A transceiver is a receiver and transmitter in the same box.
Ah, okay. That's what threw me. Okay.
Used to, they were separate. Nowadays, it's really hard to find a separate transmitter and receiver.
Okay.
How does a speech processor affect single sideband phone signal?
Bravo, because you said average. It averages it out.
It averages the power.
Right.
Yeah. Bravo.
It tries to increase the area under the curve of the signal,
Right.
which would increase the average power. What is the effect of an incorrectly adjusted speech processor?
Delta.
Delta. You said all of those.
Yep. What does an S meter measure?
The strength. So C, Charlie.
Right.
Yeah.
How does a signal, Nanette,
Mm-hmm.
that reads 20 dB over S9?
That's Delta.
Delta. We got that now.
How much change in signal strength is typically represented by one S unit?
Alpha.
Alpha.
Alpha. How much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9?
Charlie.
Charlie.
Charlie. So that's one of the things, when they talk about using power amplifiers and things, if you do a power amplifier and you double your signal, like you go from 100 watts to 200 watts,
Mhm.
you're only going to move the receiver needle a half of the S unit.
Mm.
You hardly notice it. How much must the, oh, we did that one. What frequency range is occupied by a 3 kilohertz lower sideband signal when the displayed carrier frequency is set to 7.178 megahertz?
So you're adding a 3 to the 7.178.
Correct.
So
Remember,
that's,
we're doing lower sideband.
So you raise it up.
yeah,
It's
Charlie.
you're going up, I thought. 'Cause it's low. Oh yeah. Okay, yeah, Charlie, that is the max.
Lower,
That is
Subtract 3.
yeah.
right.
I don't know what if but I did it right in my head. I don't know what I said out loud.
Well, yeah.
What? Go ahead.
I was just going to read it again because, like I said, sometimes it doesn't sink in.
Because it's lower sideband, you
Frequency
subtract.
range is occupied by a lower sideband signal.
And is that too simplistic to say lower sideband? You're going down your 3 kilohertz.
No, that's exactly
Upper
right.
You're going up. Okay.
Lower sideband is the negative side. Upper sideband is the positive side.
Okay.
Right, but I mean, when you're the lower sideband, you're supposed to bring it away from the 7/8. You're going up.
Down.
Yeah, but
Oh yeah, down. I guess down in numbers. Yeah,
okay.
down in numbers.
But
Yeah,
what
that's
they
what
were giving you
makes
here
sense.
was
Yeah.
the essentially the bottom of the phone band, which
Gotcha.
would be 7175. So you have to operate at least 178 or above to not go below the band.
Yeah.
Right.
What frequency range is occupied by a 3 kilohertz upper sideband signal with a displayed carrier frequency set to 14.347? So
So
remember,
usually
upper sideband is the
Bravo.
positive
positive
sideband.
Bravo.
Bravo, yeah.
And in this case, 1435 is the top end of the phone band for 20 meters.
Right.
How close to the lower edge of a phone segment should your displayed carrier frequency be when using 3 kilohertz wide lower sideband?
So it should be above.
Yeah,
3
kilohertz above.
So it's alpha.
Alpha.
Good. How close to the upper edge of the phone segment should you be when 3 kilohertz wide upper sideband?
So it's 3 kilohertz below the edge. So
Correct.
bravo.
Well, yeah. Bravo.
Too
Yeah,
bad
actually-
the test doesn't go in these little groupings because I got it in the groupings, but you mix these things up, I don't got it.
I don't like these answers because it should say below the top edge of the band.
Yeah.
Right.
Yeah.
It sort of assumes that. But see, it
Mm.
never said that you were at the top edge.
Right.
And you don't want to be below the bottom edge.
Right.
All right.
All right.
I'll be back.
Stop your recording.